amphiprotic salts and polyprotic acids. It's got a sort of a rhythmical lyric to it, doesn't it? Like Peter Piper picked a peck of pickles. How many peppers could Peter Piper pick? Polyprotic acids. Anyway, I digress. So here we are. We've previously looked at some videos looking at conjugate acid-base pairs and that ability to explain how certain substances can act as an acid and a base, and they have an acid-base pair relationship called conjugate acid-base pairs. And we touched on the idea in that video that there are some acids that have multiple hydrogens. Well, now we're going to learn the names for those, and we have come across these names a little bit before, but these are the syllabus points we're relating to, right? I've linked this one back in because, of course, we're still on Browey-Lonsted theory. In fact, the next inquiry question really delves more deeper into the Bronsted-Lowry theory. But it says write ionic equations to represent dissociation of acids and bases in water, conjugate acid-base pairs, and looking at these two here, which we sort of touched on in the last example, but we're going to bring it to the fore again. Alright, polyprotic acid. What does that mean? Well, poly means many, protic means proton. So basically it's saying that if you have an acid species that has the ability to donate more than one hydrogen or more than one proton. So if I was to look at HCl, that is not a polyprotic acid. It's only got one hydrogen. Okay, it completely dissociates. It completely dissociates, and it is very strong up the top, right? So it's not going back. Chlorine is not going back. It's completely dissociated. But if I was to give you H2CO3, which is called what? Carbonic acid. If I was to give you carbonic acid, it's got two H pluses it could get rid of. The first one comes off really easy. The second one, not so much. Okay, but it could do it, but very, very rarely. Okay, if I was to give you phosphoric acid, however, that one there does a lot more of this polyprotic ability, right? So it can lose the first hydrogen, right? I'm just going to write it in a simple form. Oops. So it can lose the first hydrogen to form this compound here, dihydrogen phosphate ion. Then it can get, then the dihydrogen phosphate ion can lose a H plus, and that's going to give you the hydrogen phosphate ion, right? And we don't really see the last step where it's releasing that H plus very often. Why? Well, think about it. Here we have a neutral molecule. Yes, it's going to lose that and produce a minus ion. Therefore, to lose a positive ion from a minus ion is energetically more challenging, and so that doesn't happen to a greater extent. And then to try and lose a H from a ion with 2 minus becomes even more challenging. So we do have this ability here where we can see that we have two equations that relate to this polyprotic acid. Now what do we mean by amphi? Well, amphi is a prefix in words to say two, right, or in between. So amphibian, amphibious, its ability to go on water and land. Okay, amphiprotic, so that it has the ability to either gain or accept a proton. So phosphoric acid is both polyprotic and amphiprotic. In other words, polyprotic, it can gain or lose multiple hydrogens. Amphiprotic, it can gain or lose. So this is an example of that. We could, sometimes you see in textbooks that they talk about monoprotic. That's a monoprotic acid, mono meaning one. Then we have diprotic, 2, triprotic, 3. Okay, sometimes they combine, you know, these groups that have more than one and just call them polyprotic. Okay, so just be wary of the terminology there. Sometimes in the HSC they try to give you a little bit of a trick. They'll give you an acid which you haven't seen before, and they will say the diprotic acid, and you go, okay, I don't need to know what it's called, I just need to know that it loses two hydrogens. That's it. Okay, so you've got to try and remove yourself from the confusing words that you've never seen before and look at the concept. Oh, they're talking about a diprotic acid. Yeah, that's easy. Oh, there's a triprotic acid. Yeah, pluses, so I just got to make sure my equation, my neutralization equation, that there's 3 hydrogens, right, for every, there's 3 hydrogens released for every molecule that I have of this acid. Okay, it's triprotic. So if I have 1 mole of the acid, it's going to give me 3 moles of the H+. That's the concept they're after. Don't worry about what the acid's called that you haven't seen before. Look at the terminology and go back to the concept. So that's what these things mean. Polyprotic, diprotic, monoprotic, and amphiprotic just means it can gain or lose a H+. Okay, and that's it. And I've just put this here again for you to remind you that we can have different strengths of our polyprotic acids, etc. So you can see here I've got phosphoric here. Okay, it's a medium strength in terms of losing acids, but it's very, very weak in sort of gaining. So in other words, if you had a solution that had dihydrogen phosphate in it, it can go back to phosphoric acid, but it says it's very weak. So the chances are very low, right? It's got a greater tendency to dissociate, right? Because it's a medium strength acid, it's a greater tendency to dissociate, to go across there. However, if I was to put in the dihydrogen phosphate down here, right, it would go dihydrogen phosphate to give me my hydrogen phosphate ion. That would be further down here, okay? And that means that's stronger to go backwards, right? So this part here is stronger, and the top one's more likely to go towards that way. But it can do it. So we're going to learn in the buffer section when we talk about buffers that when you're adding excess OH or you're adding excess H+, this system can cope. It has the ability to absorb those changes, and that's the whole concept about buffers. But we'll explore that concept later in the videos. So that's it for this one. Make sure you can draw your equations, that you know your acids, that you can identify acids that are monoprotic, diprotic, triprotic, which is citric acid is one of them, and what we mean by the term amphiprotic. Alright, see you in the next video. Right, before we go to the next video, I want you to check out more courses that we have here on our YouTube channel, which are just small snippets from the actual bigger courses that we have on theflipteacher.com. Of course, with all of our courses, we try to incorporate practical sessions. We have study cards, we have posters that you can print off and stick around your room and do a lot more. We have up to 68 or more videos per course. That's like 9 to 10 hours of material that really delve deep into the syllabus and looking at essential content, skills, mathematical manipulations, and a lot more. So if you like that, go over to theflipteacher.com and check it all out, and I'll see you in the videos.